Alright, in this video we're going to talk about Unit 3, Objective 5, Antiderivatives of natural log and e. So the antiderivatives of natural log and e are oftentimes going to be using u substitution. So we need to recall that the derivative of natural log of u is going to be u prime over u, which means that the antiderivative of u prime over u is going to be the natural log, except we're going to have to throw in absolute value of x plus c. So remember, derivatives and antiderivatives undo each other, so if the derivative of natural log is u prime over u, the antiderivative of u prime over u is natural log of x. We're throwing the absolute values on there because we can't take the absolute value of a negative number. Now, two places where you're probably going to see this happen. One is when you have a quotient without STDs. Or another way to find it is if you have something to the negative first power when you rewrite it. So if you think about trying to use your power rule with something to the negative first, we're going to increase the power to 0 and then divide by 0, and that's a problem, right? Can't divide by 0. With e, when we're taking the antiderivative of e to the u, the exponent will almost always be the u in our u substitution. There are some exceptions to that rule, but most of the time that's going to be our u. So to think about, or to look at a couple of problems, we'll start with this. We have the antiderivative of x to the 5th over 1 plus x to the 6th. So if we wanted to rewrite this, we could think about x to the 5th times 1 plus x to the 6th to the negative first power. So that's going to give us our u as 1 plus x to the 6th. But looking into the future, if we were to increase that by 1 and divide, we'd be dividing by 0. So we want to keep the u that we have, because that's inside, right? We have to use that u. But if we look at du, we're going to get 5x to the 5th dx. And we have that x to the 5th up there, so we have to remember move that 5 over. So we're going to get 1/5 du equals x to the 5th dx. And if you look at our original problem, if u is 1 plus x to the 6th and du is x to the 5th, we're kind of looking here at a u prime over u du situation, except we kind of have that 1/5 out there. So we know we're going to be looking at a natural log. So let's make this substitution that we just had. So we know x to the 5th dx is going to be equal to 1/5 du. We know that's going to be u. So we're looking at the antiderivative of 1 over u du. The derivative of u is just going to be 1. So really we're still looking at u prime over u. So according to our rules, if we have 1 over u, that's going to be the natural log of the absolute value of u plus c. And just like we did before, we want to put this stuff back in because we aren't taking a definite integral. So this is just a u rule to look out for. If you have 1 over u, or u to the negative first power, it's going to be the absolute value, or natural log of the absolute value. So to take a look at an e problem, integrate 0 to 15 of te to the negative t squared over 2 powered with respect to t. So our u is going to be our exponent, so u is negative t squared over 2, which is really the same thing as negative 1/2 t squared. So du, take its derivative, drop, so we have negative t dt. Well, I don't have a negative t dt, so let's divide by negative 1. And make our u substitution. So we have t dt is going to be equal to negative du. And this piece here is going to be equal to u. So when we rewrite our problem, we're going to make this a negative on the outside, right? That's a constant. Pull it out front. E to the u du. And we have to think about our limits of integration. So if we plug 15 in here, 15 squared is going to be 225, so negative 225 over 2. And plug 0 in, that's just going to give us 0. Now we have an issue, right? The biggest number has to be on top. So we have a 0 here, a negative number here, so we need to flip those. When we flip them, we have to introduce a negative 1 on the outside. So we had a negative, we're going to add another negative. So we're going to go from negative 225 over 2 to 0 of e to the u du. So let's simplify that a little bit more, get rid of those negatives. So we're going to be looking at negative 225 over 2 to 0 of e to the u du. Now we didn't write the rule for the antiderivative of e to the u because it's just the opposite of the derivative. So the derivative of e to the u is e to the u. So the antiderivative of e to the u is e to the u. So when we think about evaluating capital F of u from negative 225 to 2 over 2 to 0, we know that's going to be e to the 0 minus e to the negative 225 over 2. So that's going to be our answer. We'll keep it in terms of e. We're not going to try to figure out what decimal that is. But remember, antiderivative just means what function do I take a derivative of to get this. So the derivative of e to the u is e to the u. So we're not going to really write that rule down. If you want to, go ahead. But the derivatives and antiderivatives of e to the u is just going to be the same thing. So we'll call it quits on this video. We'll see you in the next one.